In this video, we will look at apportionment, our first method, the Hamilton method. Alexander Hamilton proposed this method that has his name. It was approved in Congress in 1791, but was vetoed by President Washington, a big no. However, later it was adopted in 1852 and used through 1911. We no longer use this method, but it is a nice way to start it. So here is his actual method, Hamilton's method in 4 steps. Number 1, determine how many people each representative should represent. The way you do that is you take the total population, the population of the entire country, and you divide it by the total number of representatives that you have. Now, currently we have 435. However, historically there were different numbers, and we're going to look at some different examples. This we'll call the divisor. It has a special name. Then you take that divisor and you divide it into each state's population and get something called a quota. Quota is the number of representatives. The proportion, right, is proportional, the number of representatives that each state should get. However, you'll many times get a decimal. So you can't give out decimal representatives. So what do? Well, in his method, number 3, you cut off all the decimal parts and just keep the whole number. You're going to call this the lower quota, all right, where we'll get started. So every state will start with at least that many representatives. Remember that if a state actually has a 0, we're going to go ahead and give them at least 1. Everybody gets 1 in apportionment. All right. This answer will always be less than or equal to the total number of representatives. So the way we give out the rest of the representatives is handled in step 4. All right. What you'll do is you'll look at the states whose decimal parts of the quota were largest, and you'll give them the next available seats until all seats are given out. Let's take a look at an example to see practically how this is done. So this is an example. It says the Bandana Republic is a small country consisting of 4 states: Apure, Barinas, Carabobo, and Dolores. You can see that the best way to think about that is A, B, C, and D. There are 160 seats in the Bandana Congress. All right. They have one, like our House of Representatives, right? They have 160. The population is given in the following table. So the first thing we're going to need is we're going to need a total population. So I'm going to grab my calculator. It's going to take me just a moment to add these up. And if I didn't make a mistake, I believe the answer is 8 million folks. All right, 8 million. Of course, that works out really nicely. That's just summing up, right? Summing up those 4 states right there. Then next, we're going to find the divisor, right? The divisor I'll write here below. The divisor is to take this total population, 8 million, and we're going to divide it by the number of representatives. In this case, given at the top, there's 160 seats, all right? So we're going to divide that and get 50,000. So that number actually is our divisor, but what it represents is the number of people, right? 50,000 people that each representative will represent. So out of those 160 representatives, they're each representing about 50,000 people, right? So what we'll then do is we'll take that divisor and we'll figure out what is the quota for each state by dividing this divisor into the state's population. So this quota right here, right? We'll take the population of each state divided by the divisor that I just made up. So in the first line, it's 3,310,000 divided by the 50,000. It's a lot of calculator work, and I'm getting 66.2. All right, next one is 53.4. The next one is 26.6. And then the last one, which is our smallest state population, will be 13.8. So what these numbers represent are the approximate, right? The approximate number of representatives that each state would get proportionally, right? Those with the largest population get more, state D gets the least. Now what we do is we initially on our lower quota, chop off the decimal point. So on the first line, we'll just put 66. On the next line, just 53, then just 26, and lastly, just 13. However, when we add those up, we're going to do 66 plus 53 plus 26 plus 13. What we find out is this only adds up to 158 representatives. Now, in our apportionment rules, we always have to give out the total number, which in this case is 160. So I have 2 seats left. So the way that I give out those seats is I look at the decimal parts, right? I look at these decimal parts over here, and I give it out to the largest decimal part. So my next largest decimal would be state D has a 0.8, right? So I'll give them one additional seat. So theirs will go to 14, right? I got a +1 there. And then the next largest decimal after that is the 0.6. So I'll give state C an extra seat, and that goes to 27. So that's 2 extra seats. That means I don't have any more extra seats to give out. So I'll leave states A and B the same at 66 and 53, and this will add up to my 160. This is my final apportionment, and that's the process for Hamilton. Okay, in the next example, we'll have you get on board just a little bit, right? This one is not a state, but really just an idea about what could happen in a family. So let's read it. Mom has a total of 50 pieces of candy. Oh, wow. And don't you know that everybody wants a little bit of that, which she is planning to divide among her 5 children. All right. She wants to be fair. Instead of giving each child 10, she decides to be fair by teaching them the value of work. She tells the kids that the candy is going to be divided at the end of the week in proportion to the amount of times each of them spends with the chores. Below is the table showing the work totals. How should the candy be apportioned? Now, we'll say apportioned because you don't give out candy in decimal pieces. You give it out in whole number pieces. And so these are the total number of minutes worked for each child. Alan, Betty, Connie, Doug, Ellie, and then the total of 900. So the first thing we want to do is figure out our divisor. Our divisor will be our 900 pieces of candy, right? And we're going to divide that. You're going to divide, I shouldn't say 900 pieces of candy, said that wrong. Our 900 minutes worked, all right? Got to get this straight. 900 minutes worked. We're going to divide that by our 50 pieces of candy, all right? And so what that will tell us is approximately how many minutes you have to work to get a piece of candy. In this case, it's going to be 18. That's our divisor's 18. Again, that represents 18 minutes per individual candy, all right? Now, all these children works a different amount of minutes. So let's take a look at building a table up, right? So Alan, who did 150 minutes of work, if we look at his quota will be found by taking the 150 minutes and dividing it by the divisor, 18, and I get 8.333333 forever. So as a good practice, I like to leave 3 decimal places. Then we would do the same thing for Betty. Okay, Betty worked only 78 minutes, and so 78 divided by 18 is equal to 4 with a bunch of 3s, right? So those decimal parts actually match. Then we would look at Connie, and then Doug, and then Ellie, and do the same thing. And I'm going to pause and let you figure out those 3 quotas. Okay, now that we have those 3 quotas, we're going to look at the lower, right? The lower quota, or the lower apportionment, which is to look at just the whole number of parts. So Alan has 8, and Betty has 4, and you can go ahead and fill in those 3 since you found out the quota. Okay, so now we want to consider our total number of pieces of candy given out so far, right? We're giving out the candy. Do we have a total of 50? No, we do not. So we have to give out the extra candy by looking at the decimal parts. So our final apportionment over here, right, should be a total of 50 pieces of candy. So how many does Alan get? How many does Betty, Connie, Doug, and Ellie? Who gets those extra pieces of candy, and what is our final apportionment? This is the Hamilton method. I hope that is making some sense, and we're going to look at more examples in the module from the author.